A clean bar, a straight bar, a uniform bar, internally sound, precisely dimensioned, carefully inspected and neatly bundled. Heavier coils, continuous annealing, pickling and liming, a quality product. These are things you look for if you use steel bars. And service is as important as product. At Bethlehem, we've kept your needs in mind, combined them with our ideas, and built a bar mill. A bar mill that's new and fast, sophisticated and precise. Our 13-inch bar mill at Lackawanna, New York. If you use steel bars, have we got a bar mill for you? Have you ever seen a bar mill that's run by computer? This one is, but not by one computer, by 10. 10 computers that make decisions and adjustments fast enough to finish bars at a design speed of over 50 miles per hour. The entire 13-inch mill is nearly half a mile long, and almost everything that moves is controlled or control-assisted by computer. At this mill, making bars this good is no accident, and it doesn't just start here. We start with a billet 6½ inches square and 40 feet long. At 142 pounds per foot, they may be the largest billets ever fed into any bar mill. Our billet yard at the 13-inch mill holds 40,000 net tons of these billets, more than enough to handle the mill's output capacity. We don't waste any time moving orders through this mill, and we're always concerned about quality. We handle each billet by magnetic crane, cutting down the chances of damage to the billet surface and allowing neat stacking in storage racks. Before charging, our operator records the heat number on each billet and feeds the information into the mill's computer system. The computer then tracks each billet through the mill. Soon, every billet will carry a metal tag that will be automatically scanned. The information fed directly into the computer. This precise tracking means less chance of mixed steel. And here's another safeguard. A metal plug attached to the last billet in each heat signals the end of the heat. And on their way to the furnace, each billet moves onto a scale. Its weight checked and recorded. The 13-inch mill uses a walking beam furnace, and careful attention is paid to just how hot that furnace should be. When they come out, billets are about 2,200 degrees hot, and they all come out of the furnace with something else, scale. We get rid of that fast. Pinch rolls and a descaler combine to break the scale, and water jets blast it from all four sides of the billet. The result, a cleaner billet surface, and after it's rolled, a cleaner bar. In the mill proper, billets may pass through all or many of 22 stands before becoming finished bars, depending on the bar's final diameter. The 22 stands are divided into 4 groups, or trains. Stands 1 through 4 make up the roughing train. These heavy-duty horizontal and vertical stands reduce the billet to about 1/2 its size, making it more manageable for further rolling. The crop shear between stands 4 and 5 is the first of 3 such shears in the mill line. These shears make head cuts on each billet for easier entry into the next stand. In the 18 stands that remain, stands 5 through 10 make up the first intermediate train, 11 through 17 the second, and stands 18 through 22, the finishing train. All three of these trains have one thing in common. They're made up of alternating vertical and horizontal stands, stands named because of the position of their rolls. These alternate rolls work the shape of the hot steel, kneading it to improve its strength and mechanical properties. The bar is not being twisted. It's being worked or rolled from vertical to horizontal shapes and back again through 18 mill stands. And these 18 stands have something else in common. They're all what we call quick change stands. To roll a different section, we can switch any of these stands with newly built-up stands in much less time than conventional mills. We do that quick switching with movable platforms and precise remote control adjustments. And we assemble our replacement stands in a build-up area near the mill line. Once a stand is built up, moving it out onto the mill floor is a piece of cake. Quick change stands mean shorter downtime for us. For our customers, more orders rolled faster. Orders for steel bars.
Okay, Reed, come ahead.
The mill's entire rolling operation is supervised from the mill pulpit, an advanced monitoring and control center. From here, operators can follow the progress of each bar through the mill without even looking out onto the mill floor. Television monitors show strategic areas, and the line of lights follow each bar through mill stands, showing exactly where it is in the mill line and where it isn't. That information is pretty important when you're rolling 3 bars simultaneously, each at a different point in the line. As the steel speeds through the stands, it gets more difficult to see all of the things that go into making a finished bar. Loopers, 9 of them in all, eliminate tension on the bar between mill stands 13 through 22. Any tension on the bar could stretch the steel that is by this time extremely flexible. The reason for that flexibility has a lot to do with bar diameter and temperature. The rolling temperature for each order is specified for best metallurgical practice and programmed into the mill's computers. The computer signals 5 bar cooling boxes between stands 12 and 22 to douse the bar with enough water to keep the finishing temperature constant and correct. Because uniform temperature means improved bar quality, there's no guesswork involved. The computer has already calculated how much water it takes to cool the bar between stands. That's just one example of how our computer's lightning calculation and decision-making abilities combine to roll a better quality bar. Here's another. A finished bar leaves stand 22 at a speed of about 4,000 feet per minute. But even at that speed, adjustments are being made automatically to the bar's dimensions. You're looking at one of the most innovative pieces of equipment this mill has to offer. It's an automatic bar gauge, and what it does is remarkable. It continuously measures bar diameter and makes micro adjustments to the roll positions in stands 21 and 22. Using this gauge, we can roll bars consistently closer than standard commercial tolerances. That means Bethlehem bars will need less work on your machines and can save you considerable time and money. From this gauge, bar for straight product heads for a cooling bed 420 feet long. On a 5/8 inch diameter bar, what started out as a 40-foot billet has by this time been rolled into over a mile of hot steel. After that steel speeds past the bar gauge, it's cut on the fly by a dividing shear into cooling bed links. This shear also cuts head crops that are routed to an inspection station down the line. At this station, bar samples can be cut, stamped, gauged, upset, even magnafluxed if necessary. Online inspection means that every bar sample gets a final metallurgical check while the order is being rolled. And it's another chance to prevent mixed steel. The cooling bed is an advanced design too. Row after row of precisely aligned teeth cradle the bars carefully to keep them straight and free of surface damage. When the bars are ready to leave the cooling bed, they're rolled out and onto a shear run-out table and cut into lengths from 7 to 45 feet. These bars are automatically stacked and bundled, and completed bundles are picked up by a stacker crane for shipment or storage. Automatic bundling means neat, tight bundles, and the tighter the bundle, the better protection during shipment. You get a straighter bar. Compared to straight product outlet, rolling, handling, and shipping coil is a different story. And the parts of the mill devoted to these are completely separate. The separation starts here at computer-controlled product switch. Once the head cut on the bar has been made, the product switch diverts the bar, in this case, to pouring reels for coiling. Bars used for coils get to these reels on one of 3 routes and are kept at about 1,500 degrees by water cooling boxes. Each pouring reel can form coils up to 5,400 pounds, the heaviest available in the world. For our customers, these huge coils mean longer runs and less waste in manufacturing steel products. These reels can also form half or third-weight coils, depending on what you need. Transferring the coil out of the tub and onto a mandrel is all automatic. So too is the entry of coil into the mandrel power and free system, a network of 10,000 feet of track that carries the coil to the inspection and compactor bander area. These heavy coils cool slowly and uniformly, giving our final coiled product improved physical properties. To track each coil, every mandrel has a code card that's read by optical scanners, the information used to update the computer memory. That makes it easy for us to know where each coil is in the network. By the time it reaches this area, the coil is completely cooled, ready to be compacted and banded. Automatic compactors make a uniform coil, and banding keeps it that way. From the compactor banders, coils can travel to the coil annealing furnace, coil pickle tanks, or the coil handling area. All 3 of these located within the 13-inch mill for fast, accurate service. A C-hook system services all 3 areas. Each coil's weight is checked on one of the system's 4 scales. The coil annealing furnace is a controlled atmosphere continuous annealing furnace, complete with its own gas-generating equipment and coil transfer system. The coil pickling tanks clean and coat coiled product. There's even a recovery unit to process waste acid. The coil handling area, like the straight bar handling area, has racks for stacking product. Here, the stacker cranes are completely automatic, programmed by computer to place or retrieve a coil. Computerized handling helps us keep better track of every coil in your order. And when all coils are rolled and ready for shipment, our system makes it easy to get all of your coils together on the shipping dock. Here's something we all like to see. If you're buying from Bethlehem, it means your coil is on its way. To us, it means we've been able to get your order filled on time with a bar so good, it practically sells itself. And that's the main reason why we built this mill the way we did. It's simple, really. The faster we can make quality bars, the faster we can get them out to you. Faster, because this is the world's newest and most technologically advanced mill for rolling alloy and carbon bars. And if you like what you've seen, we think you'll be even more impressed when you see our mill firsthand. When you do, we think you'll agree that if you use steel bars, we've got the bar mill for you.